Hello, this is Rocky, and I am going to do video demonstration for design assignment 4A. So in design assignment 4A, we use quite a lot of functions, which I have listed. Initialization for timer 0, which will be our timer to do PWM, and then I have ADC initialization for analog to digital conversions regarding the potentiometer. And then I also have the US art functions enabled. I really only use this to help guide me doing the analog to digital conversions, but since I used it, I'm just going to leave it there because it kind of makes this assignment much more easy to understand and read. Otherwise, the main function, we could see that we set pins regarding the pin for PC0 regarding the analog to digital converter input, and then PC1, I did PC1 for switch to turn on and off the DC motor. As you can see, I have highlighted green the switch for the pin change interrupt. I was having some trouble, but I have it there for reference. So I just initialize the functions, and then we could see that for the main code, we take a ADC value, which is our analog to digital value, and then we break it into making it that it always stays less than or equal to 95%. Then it goes into middle percentage, and then we when we get to lower than 5 regarding the ADC value, it just drops to 0%. This is where the pin change interrupt is meant to be, but I was having some difficulty in operating. Otherwise, I have the timer initialization and then the ADC initialization. The most important is probably the reading the ADC, in which for this component, it's similar to the analog to digital conversion for the temperature sensor, except we just read from voltage divider from PC0, and then since the max value on a voltage divider happens to be 5 volts in this scenario, and the lowest happens to be 2.5 volts, because I did a 1K, the potentiometer being max at 1K and then 0 at the lowest. So I just subtract half of it, and then I divide it by 2 so that we get an 8-bit integer value, which is this last line. Anyways, for the schematic, so a lot of the pin connections on the at Mega 328 PB, we could see that we connect to 2 main components, which the first component, we have our external capacitance with the inductance attached to a potentiometer, which we'll use this to control the values. I deactivated the pin change interrupt because it's been giving me some problems, but I left the coding just in case for reference. Otherwise, over here we can see we have the DC motor with an H bridge to the L293, I believe that's the name of the chip, which is just supposed to protect the DC motor. Anyways, I'm gonna go ahead and run the code. So everything should run smoothly, and we could see no compiler errors as it's loading the program. Oh, let's delete this. So once that loads, okay, we see it's connected, and then I have the value. This is at the lowest, and I said when it's less than 5, it drops to 0%. Which we could see that it drops to 0%. So going to the potentiometer, we could arrange the value. Let me go ahead and range it to the highest value, which is the 1K. When it's the 1K, we get to the max value, which we could see that we're at 253. Since that's above the 242 value that I have listed in the coding, I just stop it at 95%. And this is 95% on the motor. So we could even do inside values. I'm going to try to change it while holding this to the screen. We could see as I go lower, we could see the values drop, and then the percentage drop on the DC motor, and then eventually we get close to 0, and then on the cutoff is 5, which drops it to 0. So we can see that cutoff drop to 0, and then increasing it back goes up in the percentage. Looking at the actual motor, let me switch hands. So that's looking at the screen, but looking at the actual motor, oh, this is pretty hard to move. So this is at its max value. We could see 95%. That's 95%, and I'm going to drop it low, and we can see it slow down. Slowed down. See that spin? It's going to stay there, and that is 32%, about 32%. Those aren't precise values, as a heads up, because those values are rounded to an estimation, which I meant to round that to the nearest decimal, but I wasn't able to quite get to that point. But anyways, it does a pretty good job giving us an estimate where our percentage is at. And then we could see that it's a little bit difficult going up because it requires a little power to overcome its threshold. But as we go back down, it's easy to maintain that speed because it's already surpassed that threshold, so it's easy to go back down. So it can hold that spin at a lower power because it's already surpassed its threshold. But as we drop it to 0, it's harder to surpass that threshold because now it's at the very bottom. So it picks up at a very high, yeah, just a little fun fact. And that is my video demonstration for design assignment 4A. Thank you.